Okay, here we go. So, so today we are going to look into module number 5, and that is about quality tools and techniques. Basically, this chapter is very important from manufacturing and service point of view. How to maintain manufacturing or service uh, quality, and we all would like to have better quality product or services. So this chapter is about that, and it has many principles, many theories. So I will not touch about theoretical part because you can read, and it's important for everyone to know and read about that. For example, you are in management, you are in this course, and if I ask who who was the pioneer, who was the first person to start discipline management, anyone knows about that? Who is the first person started this subject or discipline called management? I have to. Any idea or any answer or any opinion? Okay, have you heard the name of Frederick Taylor? Frederick Taylor. I mean, since we are in management, you are doing MBA, you must know, because this is, like a starting point of every management students to understand. Frederick Taylor was the person who started discipline management of science of management or management science. A scientific approach of management, or you call it. He is a father figure of this discipline. Anyway, so we would like to talk about quality management today. And quality, what is quality? Quality is quality management. Can you please mute your microphone? Okay. So quality is nothing but a certain standard defined by product or processes. So quality, to fulfill that level of a standard, that is quality. And if there is a variation in the quality, that means the product or services are not up to the mark. So how we can check, how we can do that? Like, if you are manufacturing some products, let's say iPhone, and iPhone weight, one product is like 180 gram, another product is 181 gram, another product weight is 179 gram, and so on. Means this is a variation in quality. That means the price is defined based on 180 gram, and the weight of the product is going this side or that side, or lower or higher. That means lower means not good, higher means not good. That means wasting or product is not as per the standard. So similarly, a lot of manufacturing firms. So basically this concept came, the father came in the picture in around 60s. So basically these are the things you need to read, but I would like to focus on few things. So basically this is manufacturing example, these are services example. You can please read these things, I am not going to. Quality and variation. So quality, nowadays people talk about total quality management, means quality in everything that you do. Doesn't matter only product, doesn't matter only services, whatever you do, everything. Let's say, for example, total quality management in higher education, or let's say in university. That means each and every process or each and every services of the university has to be at highest level of the standard. So that is, it doesn't matter, teaching or research should be of high quality. Also the registration process, also the student service processes, also the IT process, everything should be at highest level. That is entire total quality management. So basically, this is, now I would like to say about pioneers people or who contributed in the field of quality management. And basically it started in early 90s. And first person after World War II, his name is Seward. He started process control charts, and that today we are going to look into that. Deming and Juran, these are other people. And most of the people are from physics or mathematics background, and they are the pioneer people in this field. Then Takuchi and Ishikawa. So 50 to 60s, lot of quality work was done in this time because this was an industrial time, manufacturing time, and there was a requirement of quality, and these people done a lot of work. And this North American firms had then 80s, Deming, Juran, these are the people. Then Kaizen is there, Six Sigma is there, ISO 9000 standards, and all these are there to measure the quality. If you know about Six Sigma, I mean, since you are studying this course, Six Sigma is nothing but a deviation, a standard deviation, plus minus 3 sigma, which is Six Sigma. But Six Sigma is a philosophy started by Motorola, and it means like about 3.7 defects per million products. That means if somebody is making 1 million products, only 3 to 4 defects can be considered, and that is the best quality. For example, every day 1 million parcels are shipped by FedEx or UPS. If they can misplace or they track the 3-4 parcel in million, that is considered up to six sigma quality. Similarly, like aviation also use the Six Sigma. So that is, and it has philosophy. If you get a certification in Six Sigma, black belt, if you get, you can write your own checks. And that is the industry standard. So, but you can start with Six Sigma, green belt, start with white belt, green belt, blue belt, last stage is black belt. Basically, I have Six Sigma green belt. So quality management, these are few points. I don't think I need to elaborate because you are already professionals and you know all these things, and you can read because we are not going about theoretical part. Now here we come to the statistical quality control, which is our. So here we have descriptive tools, Pareto diagram. If you remember the previous course 503, Pareto diagram, it is also called it 80-20 rules. So 80%, if you fix 20% of problems, your 80% performance can be improved. So we have this, Pareto diagram in our, just a minute, if you can see my, just a minute. So if you see statistics, quality control, quality tools. So here can you see this is a Pareto chart. That this is another cause and effect chart, and you can make fishbone diagram. You can make cause and effect diagram here, and these are the things. So basically, so here empty. Do you want lower control limit and upper control limit? So I think you can ask the question. Let me cover a few points then. So Pareto scatter plot, box plot, fishbone diagram, check sheet. Check sheet we always use whenever we go for our any shopping. We do the list and we check. Okay. So similarly in quality also check sheet is there, like before flying a So do you want me to answer your question, Marisa, or should I talk about? If you are in hurry, I can cover your questions. Are you in hurry, Marisa?
Sorry, I'm not in a hurry. I just didn't want to forget to ask.
Okay.
Yeah.
So I will read it later.
Okay, thank you.
You're welcome. So these are the few things, control charts. So we are going to look into this. So basically there are 7 quality tools which are very important. Every process and every service quality has to be checked using those things. But we have all these fishbone diagram. You can easily make control charts. We are looking, that is our thing. So few example, Pareto chart, it is also called 80-20, scatter plot, box plot, check sheet, fishbone chart, or its cause and effect, and statistical process control. So this is fishbone diagram. What is the result, or this is the outcome, and these are the causes. Pupil is the cause, method, material management, and technology. So basically, if you want to start any problem in any process, or you can start with this. This is the very first point to start, understanding the cause and effect. So quality improvement, and now we directly go into our part, which is control charts. So this is the, questions are based on control chart, and this is based on the numbers. So basically there are few charts which are important. So this is a basically visual display that plots the value of sample statistics over time through repeated observations. So if suppose, like a production line is going on. So basically, 1 point, today at morning 6 o'clock, I took the sample of 6-7 items. 2 o'clock, I took another sample. 3 o'clock, I took other sample. So basically keep measuring. And then I check whether my process is in control, production line is in product quality is in control. So basically we can see, we can do subgroup size and others. So numerical data, these are the 3 important charts. Control chart for sample means, R chart a control chart for sample range, and P chart a control chart for proportion defective. So these are the 3 important or common chart we use in our. And now XVAR chart, P chart, and R chart. So I go here. So this is. So basically you can see this is the question, and I think in we have. So you can put data in this form, or you can put data in this form, and both forms is given in the question. So we have sample, 14 sample. And now look into that. So we have 2 ways to check that. One is assistant Control charts is right here. What control chart you need? So you can see. So data collected in subgroups, if that is yes, because this is our subgroup, you can subgroup size. If subgroup size 8 or less, XVAR R chart. If subgroup size greater than 8, S and XVAR and S chart. What are you counting? If this is a continuous data, this is attributed data. And what are you counting? Defective items, defectives per unit, and you can use P chart, defective proportion chart, and here U chart. So basically most of the questions are related to here. So this is one of the option. Under statistics, quality tools. Here you go under control charts, and under control chart you have XVAR chart, R chart, S chart. You can have the combination of XVAR, XVAR S. So basically you can use these options. Okay, so here, this is the, now we have this data here in this form or this form. So I just go, we have 6. And here I go under control charts. And let's go under XVAR and R chart. Now we have two options. Observations of subgroup are in one row of column. So if we have in one row of column, that is, or we have, so this is all observation for a chart in one column, subgroup size, since we have 6 subgroup size, and that data should be this. So here you look, all observation for in one column. Okay, we have in one column, and this is what is grams is the subgroup size is 6. And now we can do this and we can get, now we have here few other things that you can understand. Levels, XVAR options, and here you can see, you can put mean standard deviation. Here you can put also lower standard deviation limit bound, upper standard deviation limit bound, this. So you can also define this, or else, so basically if you do this, you get this. Similarly, if I do the other things, means second option, statistics, control charts, and we go same XVAR R chart. Now here I have to say all are in different. And we have also the same, same option. You can define the, if you don't want to define, exactly the same chart or same range, and mean or XVAR chart is here. The third option, we go under assistant control chart, and let's say XVAR R chart. And here you can select X1, how you want to determine your numbers from the data itself, or you want to give, lower center line, upper limit, you want to give for XVAR, lower limit, upper limit, center line. For R, you want to give this. So basically I want, and you can get all. So 3 ways you can get exactly the same number. Okay, so this is P chart. Here, if you have defective or non-defective, so X bar chart, control chart for sample means, a control chart for sample range, P chart, a control chart of proportion defective. So these are the three important. Now, few principle based on that. So basically, you can read what is the meaning of this. If if any process is varying around mean, let's say, oh, so if any process varying, can you see my screen?
Yes.
Okay, so if anything is varying around center line, that's fine, but it should not deviate on one side or other side completely. So if you know mu and sigma control limits, this is upper control limit, lower control limit. Upper control limit, how you calculate? Mu plus 3 sigma square root of n. You know from the previous, what is the square root of n, what is 3, what is sigma? So if you know upper control, you can define. Now, these are the important points that you need to remember. Rule 1, single point outside 3 sigma. So basically, you can see this is upper control limit, lower control limit, and this one point is going outside of 3 sigma. This is rule 1. 2 or 3 successive point outside 2 sigma of the same side. So basically, you can see this is the second. So here, this line is 2 sigma, and 2 points are here, same on the beyond 2 sigma. 4 or 5 successive point outside 1 sigma. So here you can see this is 4, 5 points outside 1 sigma. This is 1 sigma. So you can see 1 sigma plus 1 sigma plus 2 sigma plus 3 sigma, minus 1 sigma, minus 2, and minus 3 sigma. So lower and upper, and fourth rule is 9 successive point on the same side of the center line. So basically, these are all abnormal patterns. Means if any single point is going outside the upper or lower limit, that means your process is not in control. You have to look into the system and you have to correct it. If this is also two consecutive points out of 2 sigma or 3 sigma, out of 2 sigma, then also a problem. If 4 or 5 points outside 1 sigma, this is also considered a problem. And many out of 9 or a successive point on one side of center line, this is also problem. So basically, how you look into the these how you check whether your process is in control or not. These are the different graphs you can see in your organization or quality tools, or you take the sample and look into that. Immediate, even single point is going outside 1 sigma, one upper control limit, it's a cause of concern. So these are the 4 rules of cause of concern. You remember from last class 50361 standard deviation 2 is, and you can see what is the meaning of this. This is a normal distribution on the right side, and this is basically a plot. So if you see, this is like a histogram, and this is, so basically if you are, if your process is very close to the center line, you are in good shape, or your process in good shape. And this is another thing, which is called control limits of the range. And So basically this is a for range chart. So D4 and X. So basically this is a formula. Upper control limit is D4, D2, sigma means D4 and R bar, D3 and R bar.
Professor, question on that.
Yeah,
So,
yeah.
So in the textbook, it's only provided like a chart of for the D2, D3, and D4 up to like I think 9 values. So are there any other subgroups that outside of that? And how do we obtain the D2, D3, and D4 if it goes above and beyond the 9 subgroups?
So yeah, if it goes beyond certain range, you have to also look. There are many other principles. We are not touching about those things, but control. This is upper control limit. If it goes beyond that, it's a cause of concern.
Okay.
And proportion, number of non-conforming items, and sample size. So basically, this is a proportion chart, which we know what is proportion, X upon N. So P chart, upper control, proportion plus 3. And if you remember from pi, 1 minus pi upon N, square root, and lower control limit is this. So this is ad hoc charts, so it's not important now. I would like to share a few important points, then we will talk about. This is another important part, which is capability index, process capability. And it is also called CP index. Remember, CP should be greater than 1.33. And this is, I think, one of the question is asked in fill in the blanks, and you get confused sometimes because I get emails from few students. So here, upper standard limit, lower standard upon 6 sigma. So this is CP. If CP is more than, 1 means barely capable of staying within the set. So I can show you next slide. So CP should be, look into this picture. So basically CP equal to 1. That means it is starting from here. You don't have any margin. It starts and it goes all the way to here. So basically lower standard and upper standard limit. So basically this is covering entire, means you don't have any little bit fraction here, there, it goes out of USL or low LSL. But if CP equal to 1.33, means you have here 1 sigma here and 1 sigma option, means you have this margin which is dark, this margin. If CP equal to 1.67, you have this margin and this margin on both sides. If CP equal to 2, you have this margin and this margin here and there. Basically, the rule of thumb, CP should be 1.33 plus. So basically, you get in question, your CP is coming about 1, means you have to answer there is a no margin, no safety margin. And you can simply use upper SL, USL, lower SL, and 6 sigma. So, and CP index, process capability, another process capability index, which look each separate safety margin. So minimum of upper minus lower, mu minus lower, and upper minus mu. Why? This is mu minus, because this is higher value minus mu, and this is lower value. Sorry, mu minus lower value divided by 3 sigma. So I mean, these are different Six Sigma and other things. So basically, few slides are very important in this. Now I look into the question of Marisa of what is lower control limit, LCL. You can clearly, calculate that using. So if you look into lower control limit, so N is given. Read the book chapter, all examples are properly given.
I think what she's saying on questions 8 and 9 in the fill in the blank, it says,
I don't hear.
And then the letter chart that's supposed to be there, that letter's missing. So we don't know if it's R chart, a P chart, or whatever the chart may be. It doesn't define it in the question.
Oh, is there a problem in the question? Okay, just let me check. Just a minute. Oh, thank you for letting me know if there's a question problem. Just a minute. What else question is there? Module. Okay, I will look into the question and I will check and I will get back to you as soon as possible. If there's a problem in the question, certainly I have to review it. Sometimes when you change something. So 8. So I think there's a file or data set is attached probably. I don't know. Just let me check. Oh, you don't see the gumdrop Excel file underneath of that? Because there's an Excel file. Marisa, there's a, this file is there at the end. The same file I'm using. Can you see the Excel file in your question or not? Or I can show you, just a minute.
I mean, I see the Excel file, but the question reads, use these sample statistics to construct control limits for N, and then there's a small box, and then it says chart. So it doesn't give the letter for the chart that we should be looking at.
Okay, I will correct this. Okay, this box is small. Okay, so basically it's a mean chart, if you are lifting lower control limit and upper control limit. Upper control, you can see this screen, LCL and this, it is, okay, so basically upper control, basically it is mean chart. So I will update this, this part, this box part. I have to see and calculate what is correct. It's asking, but probably this is mean chart. Okay. So this is module number 5. I will correct this issue, because I should not make a mistake. And so probably this is mean chart. And so this is module number 5. Do you want me to proceed for module number 6, which is a new and which doesn't have the text book? And it is multi-criteria decision making and project management, earned value analysis. So I will take another half an hour to do that. Would that be fine, or you want me to meet next Tuesday? Because next Tuesday will be late. The slides are right here. Everything is under the everything is under the module. So the last, so okay, if you are available, I can go ahead and I can start talking about multi-criteria decision making, which is very important topic, and we come across. So Doug, next Tuesday will be late because we have Saturday is the last day of the course. So I can start today and I will come next Tuesday, just, you know, to be there. If you have question related to something, you can ask. Okay, just give me 15 minutes to cover this. So let's say, and I will just directly go on the numbers issue. Yes, sir. We will cover module 1 to 6 and everything will be in the exam. And just a minute. Just go ahead. Okay. So the next topic has a next module has two topics. One is called AHP, where you have multiple criterias and you have to make a decision. That is called analytical hierarchy process. And it has also AHP, it has also ANP, analytical network process, and fuzzy, you know, different methods are there. This is the very basic method, which is called AHP. What is the meaning of this? It was developed by Mr. Sati in this year and 1977. So when you have, like, you want to buy a car, and you are confused that, okay, this car has this feature, this car has this feature. I like both. I like, you know, all three models. Which one is your first preference? Which one is your second preference? Which one is your third preference? Or you want to buy or you are buying a house, or you are hiring a CEO, or you are promoting an employee, or deciding you have 4 MBA programs, which one is to go? So basically, many criterias, and which is the best one? Or you want to rank, this is number 1, this is number 2, number 3, number 4. So basically, for this purpose, we call it analytical hierarchy process. And, you know, this is goal to select a car, buy a home, or, you know, select MBA. There are 3 criterias or multiple criterias, and there are sub criteria. So basically, hierarchy is there and you can go ahead. So first step in this for rating. So basically, what is rating? So it is a mix of qualitative and quantitative, both parts, mix of both parts. So just a minute, let me explain. This is the, okay, so for example, I have 2 models, or, you know, cities. And here I put Seattle, and here I put Spokane. So if I want to rate 1, 2, 3, and here I rate 1, 2, sorry, 1. Now you have to make pairwise comparison. Pairwise means cities based on any criteria that you take. Okay, let's say size or populations. So I would say Seattle is 3 times bigger than Spokane. Technically, Seattle is 3 times bigger than Spokane. So I will put, so this is a very first step in order to start. So this is 3 times bigger than Seattle. Spokane is automatically 1/3. 1/3 of Seattle, how I read. So this is very first step. So basically, if you want to go for any criteria, let's say brand, and you select Toyota, and here you say Honda. Now here you put 1, 2, 3, sorry, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, and 6. So let's say yeah, Toyota is the best, Nasir. So look into the brand. Okay, some people like Honda, some people like Toyota, some are like German, they like German cars, some like, Ford or GM. Okay, for example, my choices, I prefer 3 times more as compared to Honda. So my preference of brand is 3 times more than Honda or 2 times more than Honda. Then automatically Honda choice is 1/3 as compared to Toyota. So basically the first step is to make the pairwise matrix. So basically here intensity, and you can select, and this is the matrix you can make. So basically we are directly solving a car selection. You have 3 criteria of car. Selecting a car based on style, based on reliability, and based on fuel economy. We have 3 options. And then we have 4 options in terms of cars: Civic, Saturn, Ford, and Mazda. So we have 4 cars based on 3 style. Selecting a new car: style, reliability, and fuel economy. And we have 4 options, 4 models. Now which one to choose? Which one is number 1? Which one is number 2? Which one is number 3? And which one is number 4? So basically first we go for style. So this is very first matrix that has been made. So basically you can see, first I need to check, style and reliability, and what is my preference in terms of style, reliability, and fuel economy. So one by one: style to reliability, style to fuel economy to reliability. So all these metrics are, so I make this very first matrix, and based on my choice, based on my preference. So I just, make the same matrix here and show you style to style, reliability, and fuel economy, reliability, and fuel economy. And now I have to. So here this is style to style will remain same. Reliability to reliability will be same, and fuel economy to fuel economy will be same, because this is okay. Now we need to read from row. So read style is half preferred than reliability. So half is 0.5. Style is 50% preferred than reliability. But style is 3 times preferred. Style is 3 times preferred than fuel economy. I'm not worried about fuel economy, but I'm worried about my importance is 3 times more as compared to fuel economy. And my reliability is, so here, reliability to style is, this is half, then this is automatically opposite to. Reliability to fuel economy, I need 4 times more reliable car than fuel mileage or fuel economy. So here I go for 0.25, and here I go 1. Fuel economy to style is 1/3, 0.33, and this is 0.25. So basically, if you make this upper part, 1, 2, 3, 4, if you are able to fill this is opposite, reciprocal, like Seattle is 3 times bigger to Spokane. Spokane is 1/3 of Seattle, same thing. So style to reliability is preferred half. Reliability to style is preferred twice. Is it making sense? Similarly, fuel to style is preferred 1/3. Style is preferred 3 times over fuel. So if this matrix is correct, then you can do all very simple. Now we need to normalize this matrix. How do we normalize? You take the sum of entire thing. And this is, you are doing the sum of so if you are doing, then you have to do the normalization. And how we do the normalization? So I just go, I take this divided by the total, then this divided by 3.3. Similarly, this divided by 3.3. So this is column. Oh, sorry, I did mistake. Divided by 3.3. Similarly, I do for the second. 0.5 divided by 1.75. Then 1 divided by 1.75. Then 2.5 divided by 1.75. Similarly, I do for third column. 3 divided by 8. 4 divided by 8. And 1 divided by 8. So how I can check whether my normalization is proper? So I just do the sum of column, and I will get 1 of each column. Okay, now this is, now I go and I take the average. Now average of the And if I do this, so this is, average is also coming. So what is this? Style. This is a style. Reliability and fuel economy. So now based on this, my criterias are decided. That, criteria's weight is decided. This is 30% approximately. This is 15%. This is about 12% or 15%. Total is 100%. So style weight based on my preference on style, reliability, and fuel. These criteria weight is defined. So based on this, they just 30%, 60%, 10%. So this is called priority vector. First you normalize, then take the row average. So get the priority vector. So selecting a new car is 100%, style is 30%, reliability is 60%, fuel economy is 10%. When you solve the problem, never do the rounding. Always use the exact number. Always use the exact number. I'm also writing here exact number, because our calculation is based on that exact number. So now the second option is to check the consistency. How do we check the consistency? There is a, so you need to multiply A with X. Means this original matrix has to be multiplied with this priority vector. Then you get AX, then you get lambda max, and then you get this. So let's do the calculation. So this is my original matrix. I'm just copying here. And this has to multiplied with, these number 0.32. So I'm just writing 0.3, 0.6 as per book, and 0.1. So I'm going to multiply this original matrix. Here you can see 0.3, 0.6, and then I'm going to do rest of the calculation. So 0.3 into 1, 0.3, because this multiplied by this multiplied with this. Sorry. 1 multiplied with this. Okay. Then this multiplied with this. Then this multiplied with this. Similarly, I'm going to do second one. This multiplied with this equal to this multiplied with this. And 0.25 multiplied with this. 3 multiplied with this. Okay. So now we multiplied the main A matrix with X, which is priority vector. Now we would like to get AX. How do we get? Basically, in previous, when we got the priority vector, we average the row. But here we are going to sum all. So here we are going to sum. So we got this matrix. Now we have lambda max, this priority vector, and we are going to check the lambda max to check the consistency. So basically, our work is done here, but we are going to check whether this work has done, it has consistency as per the consistency index. So we are going to do further work to check the consistency. Our task is done here, but when we do the lambda and other, we have to do this step. We have to multiply A and X and do this. So basically 0.9 divided by 0.3. So this divided by this, 1.6 divided by 0.6, and 0.35 or whatever divided by 0.1. And lambda max equal to average of all these three. So we are going to do. So this is our value. So this divided by our priority vector is, this. We are using this divided by this, and this divided by 0.1. And now we have to take the average of this. So I take the average. If I'm selecting, it is coming 2 point. I think I made some mistake here. This divided by, I think 0.6. Okay. So we got, this is our lambda max. .05. Now further calculation is little bit, or here 3.06. So CI consistency index equal to lambda max minus n divided by n minus 1. So 3.06, we have 3 criteria divided by 3 criteria minus 1, which is coming 0.03. When it is coming 0.03, this is the scale that we always need to use. So basically for 3 criteria, this is index 0.05, 0.58, sorry. So consistency ratio equal to 0.03 divided by this index. So it is coming 0.05. 0.03 divided by 0.58, which is 0.05, which is about 5% issues. So basically, if less than 10%, evolution or your matrix is consistent. So if you do this step to check the consistency, so one question I have asked, what is the lambda max that you have to do here? You have to up to here. But if you are going to check the consistency ratio, this should be less than 10%. So if you do this, okay, fine. The next step, similarly, ranking the alternative for 4 style, and you are rating 4 models. Reliability, you are rating 4 models, and fuel economy, you can do based on the, the company gives 34 miles per gallon, 27. So you normalize this and you get the weight. Now you are able to get here. So style is 30%, reliability, fuel economy, and each of them, for example, fuel economy 30 per 24, 21, and so 30. Now how you can come to the final conclusion? Final conclusion for Civic, you are going to calculate what is the overall weight for Civic. So Civic 0.13 multiplied with this value plus Civic multiplied with this value plus Civic multiplied with this value. So overall you get weightage for Civic. Similarly for Saturn, this with 30% weight multiply plus, you get this, and you get 4 alternatives. So basically overall values, Civic is 30%, Saturn is 27, Escort is 0.08, and this is 0.35. Which is your first choice? Which is the first choice? First choice is this because it is highest. Second choice is Civic, third choice is Saturn, and fourth is Escort. So now if you want to rank them, this is first choice based on your, this is second, this is third, this is fourth. So this is AHP. That what are the application? I'm just going to share a few application. Now look into the if you want to buy a house, you have 3 houses, and these are the criterias: finance, age of the house, size of the house. You do the, it is big matrix, pairwise matrix. What is it? Then go for size, and all alternative go for, transit, and you go for all under neighborhood, age, yard, all, and then do same thing, and your house A will be 34%, B is 37%, C is 28%. Similarly, this is the real analysis. Which drink is consumed more in USA? And here coffee, wine, tea, beer, sodas, milk, and water. So based on pairwise matrix, this is the result we are getting based on matrix, judgmental matrix. And this is the real US Bureau of Statistics, or somewhere, real data, actual consumption data. And this is from, so this is very close to, you can see tea, beer, they are almost same, close to. And similarly, so which food has a protein? And So basically this is the derived from matrix and this is actual. So this is actual and this is, so basically this is a good method to do it. If you are, who will be the next, this is who will be the company CEO, Mr. Clinton, Margaret Thatcher and George Bush. Actually, this is old example. And you can make your CEO who is going to be the CEO or who. So basically, this method is very useful for making a very multiple objects and you rank them one by one. So any question related to this method?
Do you have the Excel spreadsheet that you put all of those calculation in this here? I think it's better to have some kind of Excel that links to it. I know you just show that,
Hmm?
but I'm looking for the file that you put together for the notes.
Okay, so I will make this one Word document and this I think Friday this module is open, so you can see this little document over there, which has all the steps to do. And what else? Yeah, one more topic is left, which is project management earned value analysis. So do you have 10-15 minutes to cover that?
Yes.
I'm fine.
Okay. So just a minute. Let me open. So actually, if I know correct or I read the statistics or reports, what is the success rate of projects? What percent of projects are successful? Any idea? Because I think we have some project managers or project people in our class. What percent of projects are successful or any idea? Roughly guess.
40%? I'm not a project manager. I'm just throwing a number out there.
Okay. So basically, we have, few because I know because I got introduction about them. And they said they are working in projects, so they are project manager or something. Okay, so roughly if I say only 5% projects in the world are successful. Only 5%, 95% are not successful. And basically this data is from different like PMI, Project Management Institute, Carnegie Mellon Software Institute, and so on and so forth. 95% projects are failed or they don't meet the scope criteria, or basically there are 3 are successful, 15 are considered failure. Thank you, Ron. So as per PMI, but what happened in between? Oh, PMI survey says 69% projects are successful and failure. Probably my knowledge is, but if I know, what is the definition? There are 3 metrics for project success, which is, time, scope, and cost. Thanks. I will look into this. So my knowledge is probably old and I have to correct. So, somehow, whatever you planned, if that doesn't come on time, so over cost, over time, almost that is there. So like Ron is sharing 69, 15%. I knew that, 95% projects are not successful projects because they don't, 75% my past knowledge says, and about 20%, 75% fail, 20% don't meet, late or cost, extra cost or, some scope. only 5% are perfectly successful, which means whatever you plant, that you reach. So basically, we start with three important things, which is called plant value, actual cost, and earned value. These are the three important parameters when you look into any project. What is the plant value? What is the actual cost? And what is the earned value at any point of time in the project cycle? So basically, you need to do this every week, every quarter, every month, or every day, in some cases. So basically, you can see the progress of your project. Let's say this project is going on. This project is going on today, as of today. Any day, for example, activity has to be completed by 18, and this is done. Okay. Activity has to be completed, has to be fully completed, but only 80% is completed. Activity C is should be completed by 80%, but only 70% is completed. Activity D should be done 15%, but nothing is done in this. So basically, as of today, what is the planned value? What is the planned value? So this is planned value 18 plus 10, 28 plus 70% of 20, which is 80% of 20, which is 16, and this 15% of 40, which is 6. So total planned value as of today should be 50. Earned value, what you earned, this is done completely. So you earned 18. 80% of 10, you earned 8. 14, 70% of 20 you earned, which is 14, and you don't earn anything. So this is your earned value. The third is, for example, from costing and accounting, you can get 45%. 45 is the actual cost that you invested so far. So if you know all these three numbers based on your project management, Microsoft project management tools or different tools, they can tell, what is the status today of the project, which activity and what percent is completed. So you can get all these three numbers, and based on that, you can make your decisions. So, there are few simple numbers that you need to calculate, and I tell you. So basically, let me go with us very simple. This is cost performance index, schedule performance index. These are the two things we need to calculate. And then let's go to directly into the question. So this is a very simple question to make a lemonade project. You need to make 1,000 cups in 15 days, 50 days, sorry, 20 cups per day. Every cup should be about 50 cents. Total project is, budget is $500. Okay, now when they measure at the end of day 10, 150 cups are made. Total actual cost spent is 90. So basically, you can see what is your actual cost. Actual cost is directly here. 150 cups is made. What is your earned value? Earned value is $75 because 50 cents each cup. 150 cups. What is your planned value? Planned value is $100 because by the day 10, you should have made 20 cups a day, which is 200 cups, and each cup is like 50 cents. So it should be $100. So if you know all these three numbers, and so now you can get, so this is earned value, $100. Sorry, this is planned value. This is earned value, and actual cost, which is $90. So schedule performance index is, sorry, I have to change this. Okay. So schedule performance index is 100 divided by, 75 divided by 100, which is 0.75. And cost performance index is at 75 divided by 90. So this is this much. Once you know, because you can do other things also. So here you can understand the total cost is $500. And this is your cost performance index, which is 833. So instead of $500, if it goes with current pace, current rate, it is going to be completed in $600 instead of $500. Means instead of 50 cents per cup, the cost will be 60 cents per cup. Now, instead of, this is 50 days project and schedule performance index is 70.75. So instead of 50 days, it is going to complete in 16 days extra or 17 days extra time. So, but you are on just 10th day, you have 40 days left. You can tight your processes, you can, do the corrective measure in order to minimize this loss, minimize this time loss. So this is a very simple, method, but a very effective method, because lot of project managers, they use this on daily basis to check the performance of the project.
What is that 50 over 75? What is that, the 50, what is that for?
Oh, 50 for 50 days, this is for 50 days.
Oh, okay.
The time,
Got it.
we plan to complete this 1,000 cups in 15 days, 50 days,
Got it.
sorry.
Thank you.
So yeah, based on that, you can see $100 extra cost and 17 days extra time. So basically, projects are completed within time. Projects are completed, but they fail to meet the time criteria, budget criteria, and sometimes scope criteria also. So Ron, I will read this report. Probably I will share my report also, where I read that Carnegie Mellon or somewhere. So this is called earned value analysis. Here you have, the graph that you can see. So let me, because we have projects now everywhere. So basically you can see this is red line is earned value. Actual spending is this. And the, blue, this line, this is actually planned. So if you are this indicates behind schedule, and this indicate over budget. And Microsoft project or project management tools can give you all the information, and you can observe how the project is going on, whether product project, whether HR project, any project that we take nowadays. So it's important to measure. And it comes from the data, because you have financial data, you have performance data of the project. So this is about module 5 and 6, and next Tuesday I will come online. If you have any question, anything, please feel free to ask, but I will not go over any lecture or anything. Any question? If you don't have.
I just had one question for studying for the final. Should we just look over the multiple choice questions and fill in the blanks, and that'll pretty much be what it is?
Exactly. The final exam will be combination of MCQ and mostly conceptual question, that if you know the concept clear, and then you will be perfectly fine. And I'm going to change little bit because there are few concern I have, so I'm going to make some changes in the exam, and I will let
Gotcha.
you know.
So from what it sounded like, it'll be most of it will be like multiple choice kind of stuff, and then with some calculations too.
Yeah, so basically, both combination of 50-50,
Oh, 50-50. Alrighty.
almost 50-50. I don't know, but almost 50-50.
Perfect. Okay, thank you.
You're welcome.
Hey Raj, it says in the syllabus that we have to use the lockdown browser.
Yeah, so I'm sorry, but actually, I have a plan to use from next time. This time I'm not doing because I observe many things that I can't share in the class. Let me stop recording. So